We are doing solutions to the on-paper exam for CS202 in the fall of 2019. We're on number 3, and this is the evaluate C expressions problem. We're supposed to write down the value of this expression and any variables that changed, assuming that this code right here was just run. I'm going to go split screen for this. Here we go. Alright, so we'll leave this. That's the code that was just run, and then we're down here. So for this one, the order of operations is first plus A happens. Okay, so this is actually going to give an error, because you're not supposed to do pointer arithmetic on an array variable. So if A were a pointer, int star A equals int star malloc, and so on. Okay, so let's show what would happen in that case. So if that were the case, then plus A would move to the second spot in the array, which has a 2. So you'd have a value of 2, and A would change to point to the second location. Okay, if you said error, then that was right as well. All right, J less than K. J is 14, so let's just evaluate these things. So J is 14, and is 14 less than space? As an integer, we've seen that space is 10. Is 14 less than 10? 0. Note, false is not a correct answer. There is no false in C. Okay, so I was being kind of picky here. All right, I equal J. So what happens there is you have the value of J that goes into I. So we're going to have I equal 10 as a result of that. And then the value of that expression is going to be 10. So is 10 less than the second expression? The second expression has C1 equals C2. C1 equals C2. C2 is 100. So C1 is 100. And that's right there. Okay, and is 10 less than 100? It is. So the answer there is 1. All right, let's look through this one. First, we're going to have is 3 less than 4? Yes. And we'd have and is 4 less than 3? No. Or is 4 not equal to 5? No. Yes. Yes, it is. All right, so what happens next? And or. And takes higher precedence, so we evaluate the and. You'd have 0 and, 0 is this, and you'd have or 1. And then the value of that is 1. Okay. Down to the next one, C2 equals C3. So that's going to have C2 getting the value 0. In terms of evaluating this expression, we'd have the value of that, which is 0. Okay, we'll put it like this. Over here, C2 equals C3. So this is an OR. OR has lazy evaluation, where it always evaluates the item on the left side. So it's always going to evaluate this part of the OR. And it only evaluates this part of the OR if this is false. So once it determines that this is false, then it will actually evaluate this C2 equals C3 equal I. So C2 equals, let's see, first it does C3 equals I, which is 10, and then C2 is equal to that. Okay, so that happens because we had a 0 over here with the OR. Okay, what is the value of that expression? The value of this expression is the final value of C2, which is 10, and that in terms of true and false is 1. And 0 or 1 is 1. Okay, 15 and 7. So we've got to do the bits. 15 is this in binary. 7 is this. And we want to do the AND of those. Just bit by bit. 1 and 0 is 0. The rest of these are 1s. And this is equal to 7. So if you wrote either one of those, that was fine. I equal j equal plus plus C3. Since the plus plus is before the C3, that's the thing that's going to happen first. So we're going to have I equal j equal C3 is 0. It'll be a 1. Okay, so C3 is 1, and then we're going to have I equal j equal 1. So we're going to have also I equal 1 and j equal 1. And the value of the expression is 1. A lot of people didn't put this, but if you used this inside of some other expression with parenthesis around it, its value would be 1 because that's the final value of I. Okay, B0, we have to look at B. Here's B. It is allocated 3 memory, enough for 3 integers, enough memory for 3 integers, and then all of them get the value 42. So B bracket 0 is 42. Star A plus 2. Here again we've got pointer arithmetic would give an error on an array, but if it did work, then what would happen? So A plus 2 would be 2 spots down, and then star would give the value, which would be 3. Okay, this one, I XOR j. So I is 10, which is 1010 in binary. And we're going to do XOR j, which is 14, which is 1110 in binary. And if you XOR those, 0100, which is 4. Okay, so overall we'd have 4, and then shift it by 1, which is 2. Or if you looked at the bits of 4, you chop off the last bit and you get 2. Okay, 4 plus 2 times 3 times takes higher precedence, so we evaluate that first. It's 6. And then we add them together and you get 10. Here we put in C3 and C2, so C3 is K and C2 is 100. So we have to figure that out. Those are both non-zero, so that'll be a 1. And with lazy evaluation of OR, we don't actually evaluate this. So we just say that the whole thing is 1. So if we did have something here like C3 plus plus or C3 equals 0 or something, if we did have something there, it would not be evaluated because of lazy evaluation. It already knows the answer, so it doesn't evaluate the right-hand side. Okay, so let's see, another comment here from something that a lot of people, I was surprised, were not understanding what, I guess people were forgetting that this single equal here is an assignment. Is that the first time we had it? This one had it as well. So I'll put a note here. Note that single equal is assignment, not checking equality. So equal equal is for checking equality. So what happens here with the C1 and C2? You evaluate C2 and then you store that into C1. It doesn't matter what the value of C1 is before this is run. It's not used. So you don't get the value of C1 and get the value of C2. You just get the value of C2 and save it into C1. The other thing is some people were, it looked like you were doing the equal, when you have a chain of equals like this, it's right to left. So you evaluate the thing all the way on the right. That goes into the next variable to its left in the chain, and then that goes on down the line. The most important thing is you evaluate the thing on the left and you evaluate the expression on the right and assign all the way to the left. Okay, that's number 3. For number 4, see the next video.